Hi folks, Tim Gauntt here, Director of Product Support for Hartzell Engine Technologies. I'm currently sharing contact information, so if you have any questions regarding this presentation, please shoot me an email. I want to thank each of you for participating, and a special thanks to Concord Battery and Chris Holder for sponsoring this seminar series. And with all that being said, away we go. We're basically going to talk about fundamental electrical systems. But what I've done on this one, I've added in some Robinson helicopter highlights. I did this because by request, and because a lot of you guys are working on these helicopters, and I never speak to anything specific. So I thought we'll throw some highlights in this one to see if we can, help everybody out. Notice where I have Robinson helicopter highlights and the little blue helicopter down in the bottom right-hand corner. That's going to be the sign that these are highlights for Robinson, and I'll stop and do those individually as we're going along. I have to bring this up because this data is only for reference, can't be used for maintenance or overhaul or anything else on our products. I do this because I was contacted by the FAA several months ago, and they had found a logbook entry that had my name in it as approval for doing an STC on an airplane. I guess, I'm not approved data. I'm not approved data, I'm not acceptable data. I may be a good reference, I like to think I'm a good reference, but you need to use the actual documents to do any kind of maintenance, servicing, et cetera, et cetera. I know some of you must get a kick out of that. Hartzell Engine Technology was founded in 2010 when Tailwinds Technologies purchased the assets of Kelly Aerospace Energy Systems. You can see over the years we've added different product lines, the latest being in 2020 when we purchased Aerospace Welding and Quality Aircraft Accessories. They're located in Tulsa, Oklahoma. Kind of the general aviation Hartzell family. Different products for Hartzell Engine Technologies, Hartzell Propeller, AWI, just the different product lines that we support under that family of businesses. We, Hartzell Engine Technologies, are located in Montgomery, Alabama. This is wintertime, so for some of you, sorry about that, but we have a nice winter. We do have aftermarket and OE support. Notice in a lot of red things, you'll see that the red is kind of the highlights that I'm looking at in general. We have manuals that are available through ATP. Not all of our manuals are available. They're not all published. We have some products that are considered throwaway products, and they are not to be, there's no overhauls or repairs approved. This is our first slide where we hit the Robinson, and notice that I've got on there maintenance for OE proprietary products are specific to the OE. As an example, we sell a specific starter to Robinson helicopters, a 149-12 HT -H. And that starter is OE to them. It is not a PMA unit. So any type of maintenance or ICA recommendation would have to come from Robinson themselves. Starter systems, notice again, we have a variety of Lycoming starter systems, Continental starter systems. I mean, we probably got 3 starters for every engine that's out there. Typically, you choose which one you want. I'm not big on the lightweight thing compared to heavyweight, so to me it's the application and what you're going to be using the starter for, what kind of operations you use the airplane used for. Like a flight school, I don't think lightweight starters work well for flight schools, in my opinion. Notice the blue and the Robinson, that is the starter I was talking about, the 149-12 or 24 HT-H, specific to Robinson helicopters. I have a lot of people that ask me what's the differences between those two starters, because the 149 HT is PMA'd, the 149 HT-H is not. The HT is not approved by Robinson on their units. They use the -H. There's difference in the way the solenoid connections are made. There's a jumper on the straight HT as compared to the HT-H. You basically power the entire starter on an HT right at the solenoid itself, and you have a dedicated power terminal on the bottom of the HT-H. So they are almost identical. In function, they're identical, but they are not, the approvals are different. So be careful with things like that. That's how we get ourselves in trouble. Little history, again, who needs a starter? Why do you need a starter? I mean, they just climb out there and do it. Not something we recommend. HET does not recommend hand propping on an engine, but some of you have been around as long as I have. That's how we do it. That's how we got these airplanes going in the old days. They were built for that. Later models, why anybody would think they can, hand prop a 210 with a 523 bladed prop, I don't know. But, to me, unsafe, but, it still gets done and you all know it. Kettering, this was a gentleman that the owner of Cadillac went to because he's a friend of his got killed actually hand cranking an engine. The hand crank kicked backwards, hit him in the jaw, broke his jaw, and he died from it way back in the 1900s. So the manager for Cadillac went to this Charles Kettering, said, hey, I want an engine starting device. Charles Kettering put together a group of people. They patented a engine starter device starter in 1915, and that became Delco. You all know who Delco is. They've been around forever. They were big in aircraft. They've kind of pulled back from that in the last 20 years, but at one time they were the biggest manufacturer there was on aircraft electrical products. Starter motor, just opposing magnetic fields. I mean, think about it. You're putting current into an armature, putting current into a field, and wound field, and when you do that, you have opposition. You create a magnetic fields, and you have opposition. If I take two magnets, and I take the two norths on a magnet and try to put them together, you cannot do it. It always kicks off to the side. That's exactly what a starter does. If I need a more powerful starter, use more current, more wire, and you'll have a stronger motor. Different ways, all we're doing really is converting electrical power to mechanical motion. You have permanent magnets, you have wound field coils. All of the old starters were wound field coils. Newer starters are permanent magnet, although some still use wound field coils. Permanent magnet starters are very voltage critical because you have that magnet in there. That is a set opposition. So I have to have enough voltage coming into the armature to be able to oppose the magnet opposition to get the thing to turn in the first place. So if you have a permanent magnet motor on a 12-volt system, it drops below 11, probably not going to work. 24-volt drops to 22, probably not going to work. The nice thing about wound field coils is no matter how much voltage you have in the battery, that amount of voltage is going to each side, field coil and to the armature, and it's going to try to turn no matter what. I prefer wound field coil. Motors, reduction systems, all this stuff is all part of the starter itself, but the big thing is how do you transmit that torque from the starter to the engine? All the old starters use Bendix assemblies, mechanical Bendix assemblies. Some people love them, some people hate them. It all depends. They just they've had their moments over the years. Today's starters are all solenoid style, and they use a solenoid to engage and disengage the pinion gear into and out of the ring gear. They do electrically now. Inrush current. Inrush current is that amount of current that it takes to get this starter turning, to turn that engine when it's just sitting there at rest. It goes like, whoa, and now this engine starts to turn. Once it starts to turn, now you have cranking current. Maximum on the inrush, about 190 amps. You'll run about 90 amps on the cranking current. If you put an ammeter on something and you're pulling 400 amps going to the starter, you got a problem with the starter. It's probably shorted, and you're just causing a direct short, way too high amps. Resistance creates voltage drop. Pound that into your head, because these old airplanes and stuff that we work on, or plastic airplanes, if there's a problem with the resistance between the components that you're trying to work, you're going to create a voltage drop. You create too much voltage drop, you're going to be the same boat you're in that we said with the permanent magnet. You won't have that voltage you need to make the components work as they're supposed to. Starter has damage on the ring gear teeth, and we run into this. People call up, or they'll say, hey, I need to buy a starter. What should I buy? Well, voltage is simple. It's either 12 or 24. But then there's the teeth. You got 122 tooth ring gears and 149 teeth ring gears. And you can see how they're all identified there. Basically, the older Lycoming engines, all the 720s and all the 235s use 122 teeth. The 149 tooth was everything else. The simplest way, you can look at all the all these ways you can figure it out, count the teeth. Just go count the teeth. You only got to be able to count to 123. If you get to 123, you got 149 tooth ring gear. Simple as that. Between that and the voltage, you now have a choice of whatever starter you want to put on, because the majority are cross-approved to the same engines. Kickback. Engine kickback can happen as little as 33 milliseconds and bust a starter in half. So people think, oh, I didn't see the prop kick backwards. Well, it doesn't matter if you saw it or not. It already happened, because it was an opposition between the engine being pushed in one direction and it trying to fire in the opposite direction. And when those two forces hit, something is going to break, okay? We've had situations where we'll just literally break the housing right off the engine itself. I've had people call me up, and a gentleman called me up, he said, all I heard was this whirring sound, and basically he ended up finding out that the starter was laying at the bottom of the cowling. That's what he was hearing, just the starter turning, because it cracked right off the engine. If you have a kickback, you could end up with a, like a, oh wait, let me go to this one. 149-12HT, again, Robinson, they do have a proprietary internal self-resetting clutch, and it'll automatically reset if the starter suffers an engine kickback event. And with helicopters, they're more prevalent to having kickback than not. So this is a warranty item. It's nice having that resetting because you don't have to do anything yourself. You basically just stop the start, restart, and then you're ready to go. It resets itself and you're ready to go, which is kind of nice. Otherwise, you could end up with a situation like this, where you get a starter that literally broke. This is from an engine kickback. Stressed the starter so much that it actually broke the housing, stressed the housing, and it just broke the housing itself. This is the 149 series starter. It does have, it is warranted against engine kickback. It does have a little shear pin inside, so on a normal kickback, it would just spin free, and then you take it apart, put the new shear pin in, and you're good to go. This one obviously is well beyond that damage, so this would be a warranty item because this starter is warranted against engine kickback. This is little on the troubleshooting. It talks about battery health, that type of thing. Talks about cap checks and all. But I'm going to leave that. Chris Holder will be doing a battery section for you all. And I'll let him explain that because he's the expert at this stuff. More troubleshooting. Voltage drop 0.5. 0.5 volts drop. Give you something to aim for. If you go from the battery, you've got 12 volts on the battery. You check the input to the contactor. You got 11 volts or 12 volts there, and you go to the output of the contactor and you have 10 volts, you've dropped 2 volts inside that contactor. You've got too much resistance in that contactor, it's creating too much drop. It's not going to work, change the contactor. Engine grounding or bonding, 2.2 ohms resistance. If you want to measure, say you want to measure if you have a good ground between the engine and the airframe. Find a nice bare spot on the engine, stick it with your ohm meter, stick the firewall with the other side of your ohm meter and read what you got. It should not be more than 0.2 of an ohm. I've had people call me up, oh, I've got 2 ohms resistance, pretty good. No, it's not very good. You shouldn't have any, but we got to give you something because who knows what meters you're using, calibration, things like that. Okay, IC or recommended maintenance, legacy starters, the old Prestolites, things like that, they're all in the OEA2 manual. If you need that information, you don't have to, I'm not going to make you purchase the manual, do that, just call me up, send me an email, I'll send you that. The Skytechs that we have that are the E-Drive starters, there's no recommended maintenance, 2,000-hour TBO. Legacy Skytechs like the 149NL, that style, there's no recommended maintenance, 2,700-hour TBO. And then we get to the OE proprietary. This is another highlight with the Robinson. That starter that they use, that -H, is a proprietary OE starter. So any recommended maintenance and ICA recommendations would have to come from them. It would not be on our product, and it would not be the same, well, I shouldn't say it that way. It may not be the same as a straight HT starter because we don't know what Robinson wants to have for their ICA and recommended maintenance. So you need to go back to them for that information. Prolonging service life, you got torque off fasteners, backup wrenches, do not exceed duty cycles. Big deal again, duty cycles on Skytech starters, which the 149-24HT is. Notice that it talks about cranking for 10 seconds, resting for 20 seconds. You can make 6 attempts at that, and then you got to cool it off for 30 minutes. Okay? Think about it. 10 seconds is a long time. If you're if I stop talking for 10 seconds, everybody's going to think there's something wrong. Okay? So 10 seconds is technically a long time. It's like the thing they say, 30 seconds to get oil pressure. Well, you better have oil pressure before 30 seconds, because that's a lifetime when you're looking at it that way. The only time you'll run into this is flight schools, kids learning how to fly airplanes, learning how to start engines, and hot starts. So you got a fuel-injected engine, you've been flying, you pull up the fuel pumps, it's hot out, fuel vaporizes, you've got to crank it to get the raw fuel back in the system, things like that. That's where you typically will exceed a starter duty cycle. I'll know it because if you send in for warranty and it's exceed the duty cycle, I will smell it when it comes in the door. You know what that smell is, that burned up electrical smell. All right, let's talk about Alternators a little bit. You can see various Alternator styles and types that we have, various aircraft applications. Alternator theory, single phase AC, all you're doing is using a magnet again. You got a north and south magnet, and you rotate that magnet in a wire. If you rotate that magnet in a wire, you're going to induce flow into that wire, and you're going to see that as an AC voltage, AC sine wave, positive and negative. You'll see that as an AC voltage. Can't run on a single phase. Most everything's going to be three phase or more. Think about AC generators. Magnetos, of course they're AC. Right? Isn't that why we do the maintenance on magnetos and spark plugs? We rotate spark plugs top to bottom to get the clean ones and dirty ones mixed up. We also rotate them one forward in the firing order because some of the plugs are firing negative and some are firing positive. Some inside to outside and then outside to inside. So we rotate them forward because it helps even out the wear on those plugs. Tech generators, they're all, the majority that I know of are AC output. Generators are all AC output. They rotate. If you rotate something in a field, you will have AC, but they use a commutator to convert it to DC for the aircraft system. Alternators rectify. They have an AC output and they rectify it to DC for the systems. Glenn Ferrison, this gentleman worked for Chrysler back in the old days, 1960. Seems like old days now. He created and he was the one that designed the alternator rectifier unit using diodes to convert the AC to DC. This was approved, or he did get the patent on that in 1960, and that is what allowed us to go to alternators when everything prior to that, cars, anything, airplanes, whatever, were all generators. This is a graph that shows the alternator and current that would come from, right, any kind of a rotating device. So let's just take an alternator. We'll call this a three-phase alternator. You've got a phase blue, red, and green. It's going to happen every 120 degrees apart, and in one full cycle, you'll have a complete AC sine wave. But what happens is the system can't use this. No radio can run on this. So what we have to rectify this. Well, originally, there was what they called half-wave rectification. They took the bottom half of that sine wave and just cut it off. Just chopped it off, just like that. Look how bumpy it is. A lot of bumps there. The radios would not like that. So what they did was they went to full wave rectification, and they took the bottom half of the sine wave and rolled it up on top. Now, if I take this and I change the frequency and make it turn faster, they'll pull those humps together, and I'll have a nice smooth DC. Now, this is all three-phase. All of our alternators, except for one, are three-phase. We have one alternator, our ALTFLX, which is a six-phase alternator. So if you take the same timeline from 0 to 360 degrees, double how many humps you have in there. You've already pulled it together. That's why that alternator is very, very efficient at low engine RPMs. It will carry a bigger load. Generators and alternators, I got no problem with generators. I'm an old guy, so to me, generators they just are as common as alternators from the old days to the new. The problem with generators, they had a very low terminal RPM. So what you would see is when you pull the power back, all the lights go dim. All right, you've seen it. Pull the power back on the engine, and the lights all kind of go dim because you can't turn it fast enough to keep the output at low engine RPMs. Alternators are much more compact, so you can turn them at a higher terminal RPM, which means you can turn them at a higher lower engine RPM, turn them at a higher speed at lower engine RPM, and you can keep the lights and stuff going. Different alternator products. Ford, owned by Cessna Aircraft, a lot of people don't know that. Chrysler, owned by Piper, nobody knows that, including Piper. Prestolite, we own the Prestolite, some of the different series we have. Some of the Robinson helicopters that we supply them, OE, the older styles were the ALY and ALU 8521 series, which were 12 volt 60 amp or 24 volt 70 amp. We then have our, what we call our ES products, which are replacements, new replacements for the Ford, Chrysler, and Prestolite styles. We have a JASCO alternator, which is a generator alternator conversion. And of course, Plain Power has just a whole bunch of different PMAs and STCs against a lot of our own products. We also have Robinson OE products under the Plain Power side. The later models, RH12-70, RH24-70, they are OE units and do have to come from Robinson, as they are not PMA'd. So replacements need to come back through them. Ford style, everybody's seen those, they all look the same. Chrysler styles, excuse me, this is what's called squareback. If you take that diode rectifier assembly, you can see it right up in there. In that top left-hand corner, take that off, make it round, you call it a round back. Put that on there, it's called a square back. This is the latest model of the Chrysler style, which are ancient. These are ancient alternators, although we build a replacement for them. Press light style. Notice right below the bottom of the center of the screen, there's a little, you can see there's F1 and F2. It's telling you your field terminals. People call me up and say, oh, I can't find the field. I don't know which one is F1 and F2. It doesn't matter. The alternator doesn't care. If you have power coming in one, ground the other. Switch them around, it won't care. The alternator doesn't care what direction it's turning. This is one of our ES series. This is the Alt-2. It's on a Cirrus. One of our Jascos, very easily identified because it's got the big blue housings on them. Plain power, just kind of representative, is just all the general plain power type alternators. Now, notice this one. These alternators are almost identical in the way they function and the outputs and all that, they're identical. But they are PMA'd against two completely different types of alternators. Notice the top left, you have two field terminals, bottom side, one field terminal. Left-hand side, you've got a snout, right-hand side, you do not. That's because the 9610 on the left is used to replace the old 9510s, the old Crittenden 100 amps, things like that. And you have to extend that snout down below that engine baffle, or you will not have your proper cooling, and it will burn up. The ES124 on the right is a direct replacement for like the Cirrus, the 656802 alternator that's used on the TSI 0550K engines, and that's already been compensated for that extra distance, so you don't need that snout. So they cannot be interchanged. If you're having an alternator, you have an output problem with an alternator, you got to decide what's low. Is it voltage or amperage? Voltage is controlled by input to the field and RPM of the alternator itself. That controls your voltage. That'll stay steady. When you flick something on, you'll see blink, maybe see a little blink, and that's it. Amperage is controlled by demand from the bus. The bus itself determines how much draw you're going to pull from that alternator. As long as you stay within the alternator limits, say 60 amps, you won't have any problem supplying it, and the regulator will maintain a voltage at that point. If you exceed it, you're going to pop your circuit breaker. Okay? The FAA recommends no more than 80% maximum draw on the system. So if you have like a 60 amp alternator installed, no more than 48 amps continuous on the system itself. 48 amps nowadays is a lot. Just some numbers you can use, 3 to 8, 8 to 12. These are just ways to check the actual field resistance. Just don't take them, just take them for reference only. The main thing is it remains smooth. If you slowly rotate that alternator, it'll remain smooth. There's your 0.5 volts. Full fielding is basically just taking off the regulator, disconnecting it, going directly from the battery or the output, which goes directly to your bus, directly to the field. When you run, it's going to follow the voltage. It'll follow the throttle up and down your voltage rail. And it'll just go right on up and right on down. So I would suggest you don't have any radios and stuff turned on. Auxiliary terminals are used to determine alternator out situations on twin engine aircraft and or on dual alternator systems. They will tell you if you have one alternator out. On a twin engine, you're flying along and lose the alternator. Unless you were looking right at the meter at that moment in time, you would never know it, because that other alternator would pick up the load and you would just keep right on going. So you got to have some kind of system there to tell you, hey, you've just lost the right-hand alternator, whatever it might be. 0.2 ohms resistance, that's, you know, how much the highest resistance we want to see in the system. Toys, watch the toys. We are now adding stuff into the airplane like laptops, phones, kids' toys, all this other junk, and they have never been checked for communications, for interruption of communication system. So watch the toys, because that could be a lot of your problem of picking up noise and things like that. The old days, we had cigarette lighters in the airplane. Some of you older gentlemen remember that. Those were all pulled out because they were basically a direct short in the system. Well, guess what? They're now putting them back in the airplanes to run all these toys, except now they call them auxiliary power ports. Okay? They are protected, and that's okay, but it's just kind of ironic that they're now putting all those back in there. 1 volt AC maximum. If you measure AC off the bus and you find more than 1 volt, you got a bad diode, or more than one diode on the alternator itself. Energized alternators is nothing more than an electromagnet. So if you want to see if the alternator or the regulator, which side is actually bad, just turn the battery on, turn the alternator on through the field switch. You will now energize that rotor. That rotor is now creating an electromagnet. Take a hacksaw, lay it on top of the alternator, and you should feel a tug. If you don't feel a tug, you're not getting power to the field, to the rotor assembly. If you're not getting power to that, you can't create the magnet. Go backwards and find out why. If you do have that magnetic tug, but you have no alternator output, and you've got a good circuit from the output to the bus through the breaker, you got a bad alternator. I mean, it just comes down, it's just that simple. Gear-driven alternators. There's been a lot of problems with the gear drive alternators on the Continental per-mold engines recently. It has been, the FAA looks at it as there are a lot of installation errors that are occurring. We're going to talk about those here in a minute. Excuse me. The manual to use for these is the Continental M0 Standards Practice Manual. It has superseded all the other service bulletins that were out there. Just as a review, you know, there's your numbers again. These are all reference numbers, give you something to shoot for when you're actually troubleshooting the system. Don't operate an alternator without a battery. I mean, I have people call me up, and what they want to do is they want to run an electrical system. They want to start on the battery, take the battery offline, then run on the electrical system. That ain't going to work. The battery provides that dampening, provides a place for that alternator to output to that smooths everything out. Same thing, you put a tiny battery, some of these home builds, they put a tiny battery in it and a big powerful alternator, you still might have a problem. You need some bulk of that alternator, literally electrical bulk, to be able to counteract what's coming from that alternator itself. Second thing, this is down for Robinson. Continued flight without a functioning alternator may result in loss of tachometer power. Well, now that's not going to work too good, especially in an idle helicopter, right? Because you got two needles. You got your engine RPM and you got your rotor RPM. Those typically are married together. That's how you know you're within that green arc that you can operate in. What if you lose one of them? So now, if your alternator is not functioning, it needs to be fixed. You just don't play around with that. For more troubleshooting, we do have on the Plane Power and SkyTech Aero websites. There's troubleshooting flow charts, frequently asked questions, things like that. Just go to those websites and go to support, and you'll find just a ton of information there. PMA and STCs, all this stuff, we have all kinds of products. We got OE products, PMA products, TSO products, STC products, blah, blah. And then you have to determine, is the PMA or STC eligible for the aircraft? And with STCs, are there any other STCs installed that would affect this installation? Remember, application guides are not approved. They're just strictly a reference data to give you, hey, here, put you in the ballpark what might actually work on this airplane. Okay? Think about it. You got a 182, take out the 470, put it in a 550. The upgrade alternator is approved for the airplane, but you changed engines. It may or may not fit. We got to figure that out ahead of time. Think before you make an alteration to installation instructions. If it's minor, you can do it. If you have an STC and you have a set of installation instructions, you can perform minor alterations. You're well within your right to do that. However, if it's major, you can't do that. That has to go back through the manufacturer, and of course, you may have to submit 337 and do it as an actual field approval to make the changes you want to make. 4313's been around for like ever. When I was in school, in A&P school, this was the Bible, as they used to say. The manuals were not as good as they are now. This was the best reference information that was out there. It's all acceptable data. It's not approved. It's acceptable. But it gives you just wire sizes, cable sizes for starters, circuit breakers, fuses. It just gives you everything you need to actually build an electrical system in the airplane. All the home built guys, I send them to this because I am not the reference. In this case, they need to go where they can say, hey, I did this in accordance with. Proper grounding? I don't know. Is it proper ground? Looks okay to me? Maybe not. But when you look at it, look at that big old cable hanging down there. It's got that old style cloth thing that's all coming unraveled there. Tells me that that is one old cable. Who knows what the resistance of that cable is now? Look at those other three. You know the way that they're on there, they're bent completely 90 degrees on those terminal ends. So are they good connections or not good connections? But let's try one other thing. Why are there so many? I'm going to venture to guess to say that big cable on the right there with the cloth insulation, that's probably your main ground from the engine to the airframe itself. But what are the other ones? Are these just things that over the years somebody's added on they've added on something, EGT, CHT thing or something like that. It says you got to ground it. So they go up on there and they put a ground wire on. Then they put something else on the engine, put a ground wire on. And all of a sudden you've got all these extra ground wires which can affect the operation. It's called a ground loop. And if you have a ground loop caused by too many grounds, it's searching so hard to find a ground that it actually puts resistance into the system and affects voltage drop, which we've already discussed we don't want. Okay, gear couplings. if you have a firm old engine, whenever you're doing these gear couplings, you're putting these alternators on these things, you got to be really careful because the alternators are manufactured by one manufacturer. That base gear that I'm holding is manufactured by Continental. The gear coupling that's circled, that's manufactured by somebody else. So you got all these plus and minus tolerances. All the pluses add up, not a good thing. You may take that coupling and shove it so far into that base gear that you get into that elastomer. You get into that, start grinding that off, and that dumps it in the oil system, which could be picked up and block oil passages. The other thing is when you push that coupling so far up into that ring gear, it puts the rotor shaft itself, puts it on a bind and puts it in a bending moment. So now every time it rotates, it's turning and bending. You know how long that's going to last. Not very. What I do is I like to take these, you put your coupling on, get everything done in accordance with, put a spot of dye on the coupling, install it on the airplane, install the alternator on the airplane, turn the prop through, pull it back off, and look and see where you're actually tracking. That's the only positive way to know that you're tracking properly inside there. If you don't, you may end up with this. Believe it or not, that's not supposed to be there. It came right out through the other side of the engine. So you've got a whole bunch of dams. You know this has gone downhill. It's going to be a big, expensive repair, and we got to find out why did this happen. So I look at the pieces, and I take these pieces. I say, well, there's your rotor shaft. Now look at the circle. Look at the woodruff key slot. Look how worn out it is. That tells me that that gear coupling that's right in the middle of the page there has been banging around on that shaft, which tells me the gear coupling was loose. At every power point, every power surge of the engine, every change in electrical demand, boom, 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 was pounding back and forth on that slot because that coupling was loose. I will say the coupling was loose because of that thrust washer where the arrow is pointing. I think the biggest problem we have right now is people are reusing these thrust washers. Those thrust washers have to be removed and have to be replaced anytime you take the torque off of one of these gear couplings. I don't care if it's brand new and you need to untorque it, then you put another thrust washer on, because you cannot tell me that you can get that thrust washer in exactly the same spot where it crushed that copper and everything is exactly where it was previously. Okay? You can't do it. It's impossible. So put a new one on, let it redo it, because what happens is if you torque that whole gear coupling assembly down against ridges that are on that thrust washer, it's going to loosen up, and you're going to end up with a condition you have right here, which could very easily lead to the coupling shaft coming apart, going right out through the side of the engine. SAIB, this was written by the FAA in 2018, which means it's a pretty current document, especially for the FAA. Pretty current document, and it talks to and speaks to installation of alternator drive couplings. This was an alternator that it obviously started shedding some of the orange elastomer material that you saw in the coupling, plugged up the oil passages, engine seized, guy crashed and died. They're attributing some of these problems to maintenance. And guys, we do a great job maintaining these airplanes. Don't get weird on this. Spend the $15 and buy that extra thrust washer, and I think you'll save yourself a lot of grief. Corroded terminals, I guess so. You know, it's just one of those things. If you're having a problem, you want to bust them loose, tighten them back up, you know, just to make sure. That piece that's in the middle, that little capacitor you see between F1 and F2, notice that it's on there. We don't recommend you put that back on. However, some of you guys out there reminded me that that part is in the electrical maintenance manual for the airplane and is a part that's available, so it would need to be reinstalled. Here's one where they put took the brush block assembly out. When they took that brush block assembly out, they loosened up the stud there, and notice how that stud is a carriage bolt. You can see the little carriage portion, a little square portion on the bottom. So when they loosened the top of it off, they must have also loosened the bottom. And when they loosened the bottom of that, what do we have? We now have a loose terminal connection because your shunt, that white wire, that shunt which goes down to the brush, you now have a loose terminal connection which makes an intermittent connection, which means you have an intermittent alternator and it was pulled off because of that. Okay, so we need to be real careful about that to make sure that we actually, when we tighten that down, that bottom nut, that we get that carriage that's pulled back up into the brush block assembly properly. Then once it's up there properly, then we can tighten the other nuts and off we go. Notice this one. This is one that the brush block was pulled out, and for for whatever reason, you know, they want to check the brushes or do something like that. And it looks to me like when it was put back in, they didn't do it properly, because technically when you're doing something like this, you're going to take the brushes, you're going to push them down inside the brush block, and you're going to insert like a little piece of wire, like a paper clip type thing. You shove it down through there in front of the brushes, and it holds those brushes in place. Now you can go ahead and you can reinstall the brush block assembly. When you get it reinstalled, pull that pin, those brushes will snap up against the slip ring, and you're ready to go. This to me looks like somebody had the brush block out, did not know. You know, when things like this happen, you're telling me that you don't understand, you don't know how to do something, you're not using any kind of a manual. And what happened here, it looks like somebody tried to put these brushes in, put that brush block assembly back in, and hold those brushes back in with their fingers as they were installing the brush block assembly. Well, it looks like one of them got in there right, I'll say that. One's in there correctly, but it looks to me like the other one maybe kind of slipped out, and because of that, it's now sitting sideways, and it actually ran. There was actually time on this alternator when it came back in for warranty. There was actually time on this thing, and we popped the brush block out, and this is what we found. And it worked fine right up until the time that the slip ring shorted against the shunt. You can see the shunt wire coming right up through the center of the brush. Until it hit that, it shorted. And once it shorted, of course, the alternator went offline. Probably, I'm going to bet, probably popped a circuit breaker on the field, and, you know, the rest was history. This is an interesting one. This is one where that's what I call turbine nuts, an MS steel, you know, steel lock nut. I always call them turbine nuts because I always saw them on the, you know, turbine assemblies, that type of thing. We don't use any of these. We don't use any of these nuts. So where did this nut come from? This alternator came back in. It was squawked as you know, lost the alternator type thing. Well, I don't doubt it, because if you look at the copper wiring there, that's your stator assembly, and you can see it's nice and copper looking right up until the time you get down there to where that nut is. And when you get down to where that nut is, it's got all, see where it's all white and all that's all burned up there. And the fact that that's all burned up tells me that that nut was in between, they got in between there, and it just literally vibrated, and that stator assembly wiring is coated in varnish, and it just got inside there, it wore through that, and shorted right to the stator assembly itself, right to ground. And of course, it burned everything up, and nobody's happy about that. So how that got there, I don't know. But you all know, when we're doing maintenance on these airplanes, and you drop something, one, you got to find it. Two, it will go to the most inopportune spot that it can possibly find. Think about a starter. You're working on something, whatever, and you drop something. How does it manage to find the little cup that the starter is sticking out there? How does it get inside there? It's just the way it is. So we got to be careful about things like that. This is one that is kind of an interesting one. If you look right at the kind of bottom of, well, kind of, I guess more like right in the middle of the page there, what you're seeing is the positive terminal. You see the little plus there? See that little plus? That's the output terminal for that alternator itself. That alternator cable would be connected there, and then the one to the you know, going up north, going right there, where it's all burned up there, that's actually the ground terminal. And in this particular case, this was a per mode alternator. It had the boot on it, so it's one of the ones that goes on the, you know, big old Continental engines. And they took that and they connected the terminal to the positive, and they tie wrapped the cable to that terminal, to that ground terminal. Well, you and I both know that when you're messing with those tie wraps, that thing vibrated, it just worked its way and vibrated that cable till it wore through the insulation on that cable, and that whole thing just smoked. Because you ended up with a direct short that went from the output of the alternator itself directly to ground. And you know that is just going to cause all kinds of fury. And I mean, it smoked. I mean, they were not happy about that at all. Look what happened. I mean, you know, figure out what happened. Okay, this is an alternator that was, the nut came loose, obviously. I mean, that goes without saying. And the question is, why did that nut come loose? And that's the thing that we're always trying to go back through. Whenever we get returns back in, or we hear from you guys in the field, you tell me blah, 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 a lot of times I'm going to tell you, send me a picture. Pictures to me are worth 1,000 words. They can be difficult because they can be so what's the right word? They can be so specific that it almost looks like the whole, everything's bad. But in this particular case, look at the picture. Obviously that nut is loose. Now, why was the nut loose itself? Obviously somebody's gonna call me up and they're gonna say, when you built this, you didn't tighten up the nut. I'm never gonna say that could never happen, but odds are with the systems we've got in place, that's probably not gonna happen. However, one of the things you have to do when you're installing an alternator is you do your belt tension. And you check belt tension in 3 ways. One, you can use a torque, and they'll give you a specific torque that you can use to make sure that the pulley won't slip, that the belt tension is tight enough that the pulley won't slip at a certain torque that they tell you. Second way, you can use belt deflection. So you're basically just pushing it, you're tightening it up, and you're pushing on the belt, and then I think it's usually like a 1/2 inch of belt deflection when you're pushing on it. And so you can do it that way. Third way is they have a nice little tool. It's it measures the vibrations, that type of thing. It's like a sonic thing or whatever. And you aim it right at it, and you pling the belt like you would a guitar string, and it'll tell you what the actual tension of that belt is. Kind of pretty cool. Nobody's got those things. So in this particular case, what I would say is that somebody was using the torque method, and they tightened up the belt, and then they went to check to see if it was slipping. But instead of turning the nut in the tightening direction, they tightened it in the loosening direction, and maybe the torque was a little too high, and maybe it exceeded or was close to what the torque of that nut is, and it loosened that nut up. And they didn't realize it loosened it up, but as soon as they started spinning that alternator, it was literally loose, and then you end up with this, and everything's just flying all over. This is a big deal. And the reason is think about what's there. You got an alternator sitting there. Think about a Continental engine. You got a Continental engine with an alternator, belt drive alternator sitting in the back, and you start shedding the fan and assembly. Where's it going to go? There's all kinds of lines back there. There's oil lines, fuel lines, all type of things. That this stuff is coming off there like a shot. So it's a big deal when things like this happen, and we take it very seriously. Updates. We have a whole bunch of videos. If you go to our websites, and it's whether it be aeroforce.aero or the skytech.aero or whatever, if you go to the main one, the HET Hartzell Engine Technologies.aero, and you go to that website, under the heading, one of the headings there's going to be online videos, and these are they're neat videos. I've made most of them. I made most of these. And they're on PDT testing for heaters, Permal gear coupling installations, turbo bearing clearance. How do you check turbo bearing clearance? Troubleshooting, turbocharger cool down, that's a big one, and starter duty cycle. We made all these videos just to give guys in the field and folks and pilots, and it doesn't hurt a bit for your pilots to look at this stuff, to give them a way that they can just look at something and know if they're completely out of whack in the way that they're actually doing some of their work. So it's a good way to go, just a good way to go to visit some more information. Okay, that actually concludes the electrical presentation. I appreciate your time. I look forward to any questions and comments you might have. Thank you, good luck, and God bless in 2022. Bye-bye.